So this one says we have a base area of 14 by 17 for a container. We're putting candy into this container. The candy's at a certain level right now, and the candy level is changing. So let's draw what it could be in the next instant of time. The candy has a current volume called V. It has a current mass called M. The new addition to the candy would have a volume of dV and a mass of dm. That's an infinitely small mass and an infinitely small volume. There's also going to be a height to the candy currently, but there will be a dH, a tiny change in height. All these things could be useful in our analysis. Now, they say that candies have a volume of 0.05 centimeters cubed and a mass of 0.02 grams. So from science, we always have this density formula. And a lot of times that's useful in our problems, that density is given by a mass over a volume. We can rearrange that to get the m on one side and the v on another. And then we want to differentiate implicitly, making this into dm equals d times dv. You might also see it written in this form, dm over dv. We have the mass and the volume of a piece of candy. So I'm going to do the mass of one piece divided by the volume of that same piece. So 0.02 grams over 0.05 cubic centimeters gives us a density of 0.4 grams per centimeter cubed. That could be something that we can use later on. Now let's look at some of the geometry of the situation. We know that we have a relationship between volume, length, width, and height. So V equals LWH. We want to identify what letters here are constant. So the L and the W are always going to be constant for the whole process of filling the container. So they will not become differentials. Instead, what we'll do is do a dV, leave the LW alone, and then a dH, because these things are variable. They are changing. So now we have this, and what we'd like to do next is divide both sides by a differential of our choice. In this case, the right choice to make would be dt. Alright, now let's see what they give us in the problem. They say that the height of the container is increasing at this rate. So that's a dH over dt that they're telling us. 0.25 centimeters per second. So we can plug that in now and solve for dV dt. All you have to do is plug this into here. So dV over dt then is 14 centimeters times 17 centimeters times 0.250 centimeters per second. I get 59.5. It's going to be centimeters cubed per second. So now we know how the volume in this container is changing. there's just one more step to do here. They ask us, how is the mass of the candies changing? At what rate? So, what are we asked for? dm over dt. Alright, so can we use this to find our answer? This is about a relationship between the volume differential and the mass differential. Notice that we have dv dt, but we want dm dt. So, okay, let's start with that formula. dm equals dv, and we just divide by dt on both sides. And now we can plug in and solve for the thing that we need. 0.4 grams per centimeter cubed, 59.5 centimeters cubed per second, 23.8 grams per second.